Okay, Unit 10, the first one in Unit 2, Section 10, is over unit conversions and identity ratios. So the big part of this is we are now going to be able to change from one unit to another using identity ratios. And I want to talk about that first before I get into anything else in the packet. So an identity ratio, think of the word identity, right? It kind of means the same. When you look in the mirror, you see the same thing. So one identity ratio would be 60 minutes is 1 hour, right? Those are the same thing. 60 minutes is the same as 1 hour, so this would be considered an identity ratio. We could talk about 7 days is 1 week, right? Now, using that same one, that 7 days, 1 week, we could also say 1 week is 7 days. So notice how right here we use two different identity ratios using the same information. So we can flip the fraction depending on how we need it. So we will use identity ratios like this to do our unit conversions. And I want you to write out your steps. Did you hear me? That's right. I said write out your steps, because some of these are going to be very, very simple, and you're going to say, oh, I can do that in my head. Yeah, I know you can, but when we get into 4 and 5 and 6 step problems, if you don't have the process down because you're not doing it every time, you're going to be stuck. So humor me and write your steps out for every single problem. Okay, so the first one that I want to talk about, it's example 1, so we're starting on page 83, and example 1. And example 1 says, how many days are in 16 weeks? And okay, I get it. You can do that when you're in your head. But process is important. So usually we get something that we're going to start with. So in this case, we're starting with 16 weeks. Start with it. 16 weeks. I usually abbreviate because I'm lazy. Make that a fraction. So to make anything a fraction, I start, over 1. So 16 weeks. Now, think of an identity ratio that you can use to change weeks to days. Well, using fractions. All right, if I have weeks in the numerator right here, I want weeks to be in my denominator over here so that mathematically my weeks cancel out, right? Think about multiplying fractions. So I know that 1 week is 7 days, right? We talked about that one last time. Oh, excuse me. So mathematically, my weeks cancel out, and now if you look at my labels, I'm just in days. So mathematically, we multiply across. 16 times 7 is what, 112? So I have 112 days over 1, which is just 112 days. Yeah, it really is 112. I just did that one in my head. Okay, so number 2, go ahead and do number 2 at the bottom of page 83 right now. So when you do that, you notice that you have days in the top, so you need days in the bottom. We need that so that they will cancel out. So I now have 280 weeks over 7. Now we can divide our numbers, and we end up with 40 weeks as our final answer there on page 83. Okay, moving right along to page 84. Now we're going to use something that maybe is not quite as familiar as days and weeks. So we're going to use the conversion 1 hand equals 4 inches. So we can write that identity ratio 2 different ways. All right. One way is putting the 1 hand on top. What's going to go on the bottom then? 4 inches. Oh my gosh, you're so good. And sometimes that's not good enough. We're going to need to do it the other way. So we put the 4 inches on top, and if we put 4 inches on top, that puts 1 hand on the bottom. So it will depend on what you start with. If you start with hands, then you're going to have hands on the top, and you're going to need to use this one. If you start with inches, then, well, you're going to need inches on the bottom. So you've got to pay attention to the details. Let's go ahead and go down to number 5. The world's tallest horse, Big Jake, is 20.6875 hands tall. Let's convert it to inches. So you will see that it's given here, right? They give you you start with hands, so we put it over 1. 20.6875 hands over 1. Since we have hands in the top, we need hands on the bottom. So we're going to use this conversion. And I will put 4 inches over 1 hand. My hands cancel out, multiply across, and we have 82.75 inches is how many inches Big Jake is tall. I now want you on page 84 to go ahead and do number 6 and number 7. Okay, in number 6, you notice you start with inches, so 17.5 inches. Because I start with inches, I need to put inches on the bottom, so they will cancel out. I have to divide because I've got it ends up being 17.5 over 4 hands. We have to divide to get our answer of 4.375 hands. In number 7, I start with hands, so notice the difference of the identity ratio we use. So my hands cancel out. And since 18 and 4 are both on the top, we multiply across, and the average Clydesdale is 72 inches tall. Bottom of page 84. Okay, I want you to go ahead and answer 8, 9, and 10, and then come back and check your answers. Okay, you see the two different identity ratios. One length is 8 feet, right? So you can have the 8 feet over one length or one length over 8 feet. In number 9, Secretariat won the Belmont Stakes by 31 lengths. Which identity ratio would you use? Well, if you were starting here with 31 lengths, that means length would be on the top, so you would use the ratio here in red of where the length is on the bottom. And then you use that in number 10, by how many feet did Secretariat actually win? Your lengths cancel out, and you are left with 31 times 8, so Secretariat won by 248 feet. That is going to be the end of the first video, which is the intro to conversions.